let's talk about why all the planets are on the ecliptic. Remember when we were in the planetarium, the planets all moved along the ecliptic. So they were all pretty much close to the line of the ecliptic, within 5 degrees or so. Earth is also on that line. So remember I said if we imagine that there's a record player, right? Old-fashioned vinyl record player, the sun is at the center. It's like all the planets are on the record, and they're going around the sun. If we're looking from the north, they're going counterclockwise, right? Right, the clock goes this way, so they're going counterclockwise. Earth is on there too. You would think, well, why aren't the planets just going any direction, right? Why are they all like on this flat disc-shaped thing? And remember, from our point of view, they're all on the ecliptic. Why is that? Well, we're going to discuss that. So remember, I said that that's a clue for the origin. Oh yeah, and not only are all the planets going around the sun counterclockwise, planets that have moons, like we have one moon, it goes around our planet counterclockwise. Then Jupiter has 50-something moons, and Saturn has, I don't know, 60 or 70, right, depending on how small. Eventually they're just little rocks. It depends what you want to call a moon. But they all, as well, go around counterclockwise. And here's the thing. Most of the planets rotate counterclockwise. So Earth, we rotate counterclockwise, right? So everything is going around the sun counterclockwise, and they're rotating counterclockwise. There's 2 exceptions. Venus goes backwards very slowly, and Uranus is tilted on its side. So the theory with those 2 is that they were hit early on in their development. They were hit by big objects, which was common in the early solar system. Look at the moon, look at Mercury, right? They're full of craters. So they were hit by something big that tumbled them. So planets all spin counterclockwise, except for the 2 exceptions. Venus spins backwards very slowly, and Uranus is tilted on its side. Okay. So why is that? Well, you all should have watched the videos that I posted. One of them talked about origins, and it used a good analogy of picture somebody making pizza. I'm thinking, pizza? Is that a good analogy? Yeah, that's actually a really good analogy. Let me tweak this in. It's a really good analogy because the physics is the same. So if you have a person, they have a ball of dough, right? And you'll see this, they throw it up in the air and they spin it. Well, it will flatten into a disc. It spins out this way and it flattens into a disc, right? They throw it up in the air, right? And it's a flat disc and they put it in a pan, right? So they start with a ball of dough, they throw it up in the air, spin it, and it flattens, and, right? They're quite skilled, these pizza makers, if they're practiced. Then they have a flat thing, they put it in a pan, and they make pizza. Well, why does that happen? Well, the dough, of course, it has an elasticity, right? The dough all sticks together. It's not like a bunch of sand that just falls apart. It has an elasticity. So when you spin it, there's a centripetal force that pushes out this way. But it's only where it spins. The top and bottom don't have that centripetal force. The centripetal force is only where it's spinning, right? So it flattens out. The top and bottom don't have that, so it flattens out. Well, what happens is that in space, the laws of physics work the same as pizza dough. And so what I'm showing you now isn't just for our solar system. We see this everywhere. We see examples of this all throughout the cosmos. So if you have a big cloud of gas and dust, and these things are common. Nebula are everywhere in space. We see these big gas clouds. It's just like, a cloud that you see on Earth, a cloud that you see up in the sky. It's a thing. You can see, well, that is a cloud, right? That's a cloud. There's another cloud. So in space, you have these big clouds of gas and dust, right? And our galaxy turns. Things are moving in space quite often. So if this thing is spinning in a direction, well, it's now kind of like the pizza dough. Now the pizza dough, I said, had an elasticity that held it together. Well, this big, you know, parcel of, or this big glob of gas and dust, it has a net gravity. The center of this thing has a net gravity. So all of these particles are actually, they're kind of attracted towards the net center, But if it's spinning like the pizza dough, it will eventually flatten. It will eventually flatten out, just like the pizza dough, where you have a centripetal force. The spinning motion will keep these particles at the center. It will keep them spread out, whereas the top falls in because of gravity, right? It falls in. Well, there's no up or down in space, so the bottom falls in as well. And that is the secret. It's that simple. That is the secret of why all of our, so now you would have, eventually you'd have the sun at the center. Well, here, you know, it hasn't formed, there's a lot of gas and dust. Eventually this will get all cleaned up, like in our solar system, where it's pretty much cleaned up. There's still comets and asteroids flying around, right, when we get hit by meteors. But it's pretty much cleaned up. And you have planets will start forming because they're spinning as well, right? So that's what it's showing here. Planets are forming. And it's a disk, so it's a very common occurrence, and this is thought to be the major mechanism in all stars. Also, and stars, they've discovered thousands and thousands of planets now that are orbiting other stars. Right, our sun is just a star. There's thousands of other stars that have planets, and it's all the same sort of thing. Just like a ball of pizza dough, right? This disk formation happens, and you get, in our case, solar systems, right? Our sun, and you get these star systems where planets are forming, and that's it. That's the big mystery of why, when we were in the planetarium, why was everything on the ecliptic? Why were all the planets on the ecliptic? Well, it's like pizza dough, folks. Yay! Isn't science fun?